Hello, this is the recording for section 2.3, Modeling with Linear Functions. Modeling with linear functions or applications involving linear functions are pretty straightforward. Recall that every linear function can be written in the form f of x equals mx plus b, where x, of course, is the input, m, of course, is the slope or rate of change, in your function, and b, on the graph, that would be your y or vertical intercept, or you could consider this your initial value in a function. All right. So when we model with linear functions, we want to use data to try and write a function in this format. So one thing that you will always need is your rate of change, or your slope. And of course, to calculate that, if you have two ordered pairs that satisfy the equation, right, or two sets of inputs and outputs of the function, we can find that rate of change by finding the difference in the outputs. We could write that as f of x2 minus f of x1, or x1 and x2 are inputs to the function, and then divided by x2 minus x1, right? The difference in the outputs divided by the difference in the inputs, or over the difference in the inputs. All right, so given these two formulas, we can model any linear function or any linear situation. So here's an example. This is kind of an old-fashioned phone company, all right? There's a cell phone plan where a customer pays a flat monthly fee, okay, and then a certain amount of money per gigabyte of data used on their phone, right? So that's telling us there's a fixed amount they have to pay even if they don't use the phone, but then there's also an amount that changes based on how much data is used. Okay? If a customer uses 2 gigabytes, the monthly cost will be $37.80. If the customer uses 4.5 gigabytes, the monthly cost will be $66.30. All right, so part A says find the linear equation for this monthly cost of the data plan as a function of G, the number of gigabytes used. All right, so we're looking for a function here that we can use to determine monthly cost. The input to that function, because this function is going to be of G, or the number of gigabytes used, that's going to be the input to the function. So our functions will look something like this. Call it C for cost. We'll call it C of G, right? And then we need to figure out what that function is going to be, okay? Well, it's going to take this format here, mx plus b, right? Let's go ahead and write that right up here so we can be looking at that. All right, so what we need to determine here is the rate of change, and our initial value. Well, what is the rate of change in this situation? I don't know. It doesn't really say what it is, but we can find it, can't we? Right? We know two sets of inputs and outputs here. The input to this function is going to be G, the number of gigabytes used. The output is going to be the cost. So with the data that we have, 2 gigabytes results in a cost of $37.80. 4.5 gigabytes results in a cost of $66.30. With those two sets of inputs and outputs, we can determine the rate of change, right? Because again, the rate of change is the difference in the outputs over the difference in the inputs. All right, let's see if we can calculate that rate of change here. Well, what are our two ordered pairs? Let's write them first. Maybe I'll put it over here. The first set of inputs and outputs would be 2 gigabytes and then the cost for that is $37.80. The second is 4.5 gigabytes for a cost of $66.30. So those are two ordered pairs. So we could kind of say this as an X1 and an F of X1 here, and X2 and an F of X2 here, right? So applying the formula then, my rate of change is going to be 66.30 minus 37.80, right? That's my F of X2 minus F of X1 over 4.5 minus 2. That's my X2 minus X1, right? If I put that in my calculator, figure out what that is, that's going to be 66.30. Let's move it over there. Minus 37.80. All right, that's 28.50, and we'll divide that by 4.5 minus 2. Of course, is just 2.5, and we see that it is 11.4. Now, what does that mean? That rate of change. What does that mean? That means for each additional gigabyte used, the cost will increase by 11.4 or $11.40. That's what our rate of change is. All right. So I can start writing my model here. I can start writing my function. I know my rate of change now. It's 11.4. Right? So if f of x is mx plus b, c of g is going to be mg plus b. Well, do I know my initial value? That's going to be my initial value. Do I? Well, I do, because look, well, no, I don't, but I do know that there is one. It's a flat monthly fee, right? It's a flat monthly fee. So we need to figure out what that initial value is. Well, how might we do that? Well, we'll just use one of these ordered pairs that I know satisfies this equation, plug those values in, and solve for b. Okay, I'll just use that first ordered pair. I know that a cost of $37.80 results from using 2 gigabytes of data, so that'd be 11.4 times 2 plus b. And I would just solve for b. Well, let's see, 11.4, that's 22.8. 37.80 is going to be 22.8 plus b. Subtract that 22.8 from both sides, and I know that b, my flat monthly fee, is going to be 15. So I have to pay $15 even if I don't use my phone, right? So that's what the model then is. C of g equals 11.4 g plus that $15 flat monthly fee. All right, now we've got the model. Let's use it. Let's use that equation to find the total monthly cost if 7 gigabytes is used, all right? So if G is 7 gigabytes. So the cost of 7 gigabytes, or C of 7, right, is going to be 11.4 times 7 plus 15, which is $94.80. 94.8, which of course as a cost is $94.80. All right? Pretty straightforward. All linear functions take this form here. It's going to be the rate of change times the input plus any initial value. We can always find the rate of change if we have 2 sets of inputs and outputs. Let's look at one more example here. See, we're trying to choose between 2 window washing companies. The first company charges just $5 per window, right? The second has a base fee, right? $40, so that's like an initial value, isn't it? You got to pay that $40, but then they only charge $3 per window, okay? So if I call the second company, I pay $40, but then only $3 per window. First company, they'll come to your house for free, but they're going to charge you $5 per window, right? So if you only have a couple windows to wash, it's probably going to be better not to pay that base fee, right? And do the $5 per window company. But if you have a house with a lot of windows and they all need washing, it might be better to use the second company where you pay that base fee, but then the per window charge or the rate of change is lower. Well, this would be a valuable question I would want to ask if I was choosing between these companies. How many windows would I need to have washed for this second company to be preferable? What is that number of windows that makes that second company cheaper? Well, I need to think about my two models. My first company, we'll call that f of x. My first company, the rate of change is 5, right? So 5 times the number of windows cleaned, if we let x be the number of windows, okay? 5x, but there's no initial value, so the b would be 0, so it's going to be like a plus 0, right? The second company, however, call that one g of x. That second company has a lower rate of change, so 3 times the number of windows cleaned, but there is that base fee, or that initial value, if you will, of $40. So how do I know when this one becomes cheaper? We set them equal to each other and solve for x, our number of windows. I should have written that down. All right, so then 5x is going to equal, I don't need that 0, right? 5x is going to equal 3x plus 40. Subtract that 3x from both sides, so 2x is 40, divide by 2, and I see that if I have 20 windows to clean, it wouldn't matter which one I charged. If I had, or which one I hired, they'd cost the same. However, if I had 21 windows, the second company would be better, right? So I might say at 20 windows, or for 20 windows, I don't know where to say that. For 20 windows, the cost is the same. For 21 windows, the second company is better. I'm going to say the second company costs less. Okay, straightforward, pretty straightforward. All right, that ends the lecture on modeling with linear functions.